Hey everyone, this is Eric Sloov at the VMworld 2018 and I'm joined by Frank and Michael. How are you doing, guys?
Good, good, good. Last
Awesome.
day?
Thank you.
Last day, exhausted, want to go home?
Well, no, but it's always, there's so many people you talk to, there's so many interviews that you do, the sessions that you put out, it's always awesome.
Right. So both you guys delivered a session regarding running Kubernetes on vSphere. Kubernetes is everything about containers, and a lot of people think that's already virtualized workload. Why would I run it on vSphere?
So the thing is, vSphere provides you a abstraction layer. And for the last 12 years, for most people in Europe, 2005, we had the start of virtualization. We started to discover many good things about virtualization. The mobility, but also the abstraction of hardware. So when one host fails, you have, for example, HA, but also for patching, maintenance reasons, you want to have an abstraction layer. So you can move your workload to another host, to another physical platform without downtime of your services. Now, that's not always possible when you do that bare metal. And I think that's the highest quality or the best reason to run it on vSphere.
Okay. Regarding Kubernetes, we know there is a product that integrates with vRealize automation. It's called Admiral. Is that the management part?
Well, so Admiral, we started Admiral a little bit before we had really Kubernetes integration, native Kubernetes integration in the vSphere. So Admiral is more a management framework for native containers, but also container frameworks. So it's like it sits side by side to Kubernetes, if you will. But going forward, we'll see more deeper integration of vArray and, for example, the VMware PKS container service for Kubernetes. So you'll see tighter integration of vArray and Kubernetes going forward.
Okay, so if I'm going into vArray and create a blueprint, I'm not dragging a container onto a VM, do I? I'm dragging a container onto the vSphere platform?
Right now we see a lot of customers using the blueprint templates, VM templates, and then hand it over to teams to deploy Kubernetes, or like have maybe Ansible scripts in vArray and workflows to then do post-provisioning tasks. Well, going forward, as I said, you will see way more deeper integration in the VMware automation services, which means you do actually track containers or images onto your blueprints to have the full stack covered.
Okay. So Frank, when we are using vSphere as a virtualization layer, can we also benefit from all the features like HA, restart priorities, DRS migrations?
Yeah, for sure. So one of the things is within Kubernetes, you have, there are called nodes, and you have some nodes that provide the control plane, and some nodes that provide the platform to run your workload on. Now the control plane, they are built up with many different services. So one of the things is the etcd cluster, if you do it in an HA fashion. That's the state of the cluster. So those are the things that you want to have restarted before you restart your master nodes, so that's the control plane, and before you restart your worker nodes, the nodes for your workload itself. So with HA restart priorities, you can identify these are my virtual machines that run the etcd cluster. If you spin that out of your Kubernetes cluster, then restart the master nodes, the control plane machines, and then the worker nodes. So when the worker nodes start, they are fully operational, the whole cluster is operational. And that's an orchestration level that is very well known to a lot of people because they've been using VMware for a long time. So you use your current tool set and your current skill set. And I think that's a very valuable thing to do in today's world.
Yeah, it's best of both worlds.
Yeah.
Okay. And when we look at the resources that are used by Kubernetes containers, can they also benefit from things like HyperThreading?
For sure. So we provide the platform. So the scheduler from ESX decides where to run it and how long to run it. And if it uses HyperThread, we know that sometimes it shares some resources with another workload. So when we detect that, we will start to compensate the time it spends on the CPU core, and then provide a particular accounting so it allows to run again and again. So it's a real fair scheduler. Now, if you do this natively, and I think Michael can talk about that, it becomes a far more difficult problem to manage.
Yeah, maybe you can elaborate a little bit.
Yeah, so the thing is, the question to us is, how much do I, like complexity do I put down into the vSphere platform, or do I have to, or want to manage in the upper layers, like the Linux operating system? Because containers are like just Linux processes at the end of the day. So what we advise, and what just Frank was alluding to, is just try to push as much as complexity down to the vSphere hypervisor, which has been like made robust and efficient over the last 20 years, and just use Linux as the kind of foundation for bringing up the Kubernetes and containers, meaning that you, for example, don't expose NUMA, you try to not expose NUMA to the Linux operating system, but let it handle by the vSphere hypervisor, so you don't have to manage NUMA optimizations in the Linux cast. Like this is one of the optimizations.
Right, right. Can you tell me something about the history? Where does it come from, Kubernetes?
Yeah, so Kubernetes kind of was open source by Google, but it goes way back to the beginnings of Google itself, like Google Search, for example. So Google, like today's most enterprises, also went through a cycle of how do I build scalable global platforms or applications and services. So like Search, for example, in the beginning. And over the time, they created more and more services like Google Analytics or Gmail and other services. So they always had to solve the same problems of distributed systems and scale and resource management. So they were thinking about how can we abstract that. So they built something called Borg, which is the cluster manager. And then over the time, like they made Borg more robust and efficient to really gain efficiency and utilization, like up to 90 or more %. Now, at some point, they saw that Docker by .cloud, the company by then, open sourced their tooling, which eventually became Docker, the Docker container, Docker image, and the toolbox. And now they had like this open source toolbox to wrap and build and ship applications. Now Google was thinking, well, this is a great opportunity because you just don't want to manage one container, you have a fleet of containers. Now based on the experiences with Borg internally, they were creating Kubernetes. Like it's not a replacement for Borg, it's quite kind of a new open source based on the lessons learned on Borg for the community, and though they open sourced it.
Okay, I think that's some great history. So Frank, one last question. When we talk about vSphere, can Kubernetes also benefit from NSX and vSAN?
Yeah, so NSX-T is designed to run for use containers, or actually provide services for containers. So it's the natural fit. So the moment you use Kubernetes, we strongly recommend to take a look at NSX-T as well.
Okay, and vSAN storage, is that good? Does it need a lot of IOPS, or is it based on the type of workload?
Well, the beautiful thing of vSAN is that it scales. And another thing is that your storage policies allows you to define the storage capabilities for your workload. So now you can think about what type of storage services do I need to run my workload on Kubernetes, and that can be different from running a workload like a database workload or a low latency workload. So that's the beauty of vSAN. You have per VM type of services.
Yeah, and when you run out of resources, you simply add a host to the cluster, more CPU, more memory, more network bandwidth, and more IOPS and capacity.
Exactly. And if you look at what we're doing with VMC, with VMware Cloud and AWS, we have elastic DRS and we have elastic vSAN. So now, if you run out of resources, you can just either do it with an API call, or in the UI you can request for more physical resources, and VMware Cloud and AWS provides you. So you will scale out your cluster whenever you want, right, without any waiting time. And it's the same thing with vSAN. So I think that's a perfect match.
Great, great. Well, guys, many thanks for the interview, and I hope your session was well received.
I think so.
Okay.
It was a full house.
Great, thank you.
Thank you.